What's a core network which is used in 4G? What name we can call it as? EPC, correct? So this is evolved packet core. Okay, so this is 4G core network. Okay, so core network is nothing but so whatever the modifications, whatever you are deploying, that should be present in your core network. Okay, and 5G, it is 5G, it is 5G NR. Okay, so this is 4G core network. This is 5G core network. See, normally they will call it as for 5G core network itself, and for 4G they will call it as EPC. Okay, yeah. So this is core network, right? So what is the base station which we are using in 4G networks? That also we have discussed in last class. For 4G, it is E node B, and for 5G, it is G node B. Okay, so this is nothing but your base station. Right? 4G, it is 5, sorry, E node B, and this 5G, it is G node B. Okay, so this is nothing but your base station. So normally, how your call is connected to a core network, right? So you have a user equipment. So just consider this is a mobile phone. Okay, yeah, this is mobile phone. That is, we can call it as user equipment. I'm going to connect this mobile to a core network. Okay, how it will be connected? This is connected to a base station. From the base station, this will be connected to a core network. Right? So this is your user equipment, and this is your base station, and this is your core network. Correct? So in terms of 4G, a user equipment which is connected to a base station, this base station name is E node B. That is what I've written here. Okay, and this core network is EPC. Okay, right? In olden days, that is for 2G network, what happened is this mobile equipment which is connected to a base station, and this base station will be accessed by using a centralized controller. This is in 2G, 3G networks. Okay, so when the next generation comes, what happened is they removed the centralized controller in 4G, especially in 4G. They removed the centralized controller, and whatever the things which is provided in the centralized controller will be given directly to the base station. That means this base station will has BTS, BSC. Okay, so BTS is nothing but base transceiver station. So base transceiver station is nothing but you are going to transfer a signal. Okay, so this will act as both transmitter and receiver. That means this base station will receive signal and also transfer signal to the next block. That is called as BTS. Okay, I told you right. Olden days in 2G, 3G network, they have a centralized controller, as I said, right? So this is your centralized controller. And 4G, they removed the centralized controller, and this controller, which is placed inside this base station, which we can call it as base station controller. And this is not happened in olden days, that is in till 3G networks. Right? In order to have enhanced capability, we are removing the centralized and we are placing this inside this base station. Correct? So normally, if you are going to call via this mobile equipment, this call will go to the base station, and from the base station, this will go to the core network. So core network, as I said, you have two core networks, 4G core network and 5G core network. Correct? If you are using 5G core network, you can experience a better data rate, less latency when compared to 4G. Correct? Okay. And now, after this 4G, you have 4.5G, that is LTE. Correct? Correct? This LTE, which can call it as ELTE, the base station of this 4.5G LTE, which we can call it as ELTE. Now you have to know the difference between what is E node B. E node B is the base station of 4G, and ELTE, which is the base station of 4.5G, that is your LTE, and 5G, you have 5G in. Correct? Right. Now, from this base station to this base station, okay, sorry, from this mobile equipment to this base station, okay, you are going to access radio, right? Radio signal. Okay, because from this mobile station to the base station, this is connected by a radio signal. Okay, so which radio signal which is used here is running for 5G, correct? And for 4G, last class we have discussed that half an hour. I have given some definitions and terms. 5G RAN, which is used this radio access, which is used for 5G. Okay, and for 4G, U-turn. U-turn, Universal Terrestrial Radio Access Network. And 4.5G, EU-turn. Evolved, okay, U-turn. Right up. So now you know the basics of this, correct? You have a mobile equipment. If you want to access the 5G network, okay, so what the operator will do is they will do some modification to the core network. Say for an example, Geo, Airtel, or some other providers, service providers, they want to give some modification that will be provided in the core network. What kind of modifications in that 5G? Say for an example, EMBB, URLCC, correct? Enhanced mobile communication, and URLS lower latency. So that kind of modification that will be done in the core network. Okay, so who can do this? Who can have the access? The access which is done by the service provider. Right? As of now, it is okay, right? You have know the basics of this. Correct? Now I'll come to this point. 5G deployment models. Okay, so what does 5G deployment model is? How your 5G is evolved from 4G or from 4.5G. Correct? That we are going to see. In that, we are going to discuss about two things. One is stand-alone network, another one is non-stand-alone network. Right? So stand-alone means which base station which is used for 5G? The name is G node B. Okay. The G node B can access the core network without the help of 4G. We can call it as stand-alone network. Why? Because, okay, so not over the entire night, okay, we cannot transfer from 4G to 5G. Correct? So we have to do some deployment models, okay, for the modification from 4 to 5G. Correct? So in that, what is the deployment model consist of? Two things. One is standalone, another one is non-standalone. So standalone means the entire network which is designed only for 5G. That means you will have a 5G base station, you will have a 5G core network. This we can call it a standalone network. Correct? So non-standalone network means with the help of 4G, I'm going to transfer to 5G. Correct? And this standalone network is still under research. It's not fully deployed. Why? Because now, as of now, we have transferred a part of 4.5G network into 5G network. Not entirely we are focusing on 5G networks. So that is in the research. Okay. So in the deployment mode, if you have a 5G base station, the 5G base station can access the 5G network means this will come under standalone. The name itself, it can stand alone. Correct? And non-standalone is With the help of 4.5G network, I'm going to deploy 5G technology. That is non-standalone. Okay, with the help of 4G only, I can do it. But as of now, the service provider is providing non-standalone network only. Correct? With the help of 4G only, they are developing this 5G. So this is comes under non-standalone. All the service providers till now they are using this non-standalone network. That means any example how it works? I told you right. So this is E node B for 4G and this is G node B for 5G. Okay, how this thing can happen is for non-standalone network. Okay, I can use this base station. With this base station, I can connect to 5G 4 net. Are you able to understand? So this will comes under 4G. With this 4G base station, I can connect to the 5G core network. Correct? Because we are moving a bit slowly from 4G to 5G. Correct? So a part of 4G network which is still existing now. Correct? So that is the meaning. I am using the 4G network of base station, right? And the core network of 5G to giving 5G technology. Correct? So that is standalone, non-standalone network. Correct? We are going to see detailing about what is standalone, non-standalone. But just understand, if it is a standalone network, you will be having a 5G base station and 5G core network. If it is non-standalone, you can have 4G base station which can connect to the 5G core network. Okay, that we can call it as non-standalone. Able to understand? Right? So we'll see that. First come to this picture and it's easy for you guys. Right. Okay, right. So what is ELTE? What is this ELTE? 4.5G. The base station of 4.5G network. E node B is 4G network. Okay. So the mixing up of 4G and 4.5G, this base station which comes under. This G node B 5G. So this defines the base station which is present here, which is your 5G base station. And this is also your 5G base station. Correct? Now, this is your core network. Okay, how your process takes place? Say for an example, here the user equipment is here. Okay, how your user equipment is here. How the process call flow will be? From the user equipment, it will goes to the base station. From the base station, it will goes to the core network. Correct? That's what I've explained there. Right? Same as here. Okay. So now the deployment of 4G. Okay. So how I can access this core network? In two ways. Correct. So one is non-standalone, another one is standalone. So now you tell me what is a standalone network which is connected here, what is non-standalone network which is connected to the core. So this is core and this is your interface. This interface is your 5G interface. We can call it as next generation interface. Okay. So interface is nothing but which is used to connect between two devices or not two technologies. Right. So here the base station and core network which is connected by using this interface. Right. Now, this NGC is nothing but new generation core network. That means which network it is? Sorry, which core network it is? 5G. Okay, so new generation means it is 5G only. Okay, next here, new RAN. What is RAN? Radio access network. So this is which is using the radio signal to access the network between mobile equipment to base station and from base station to core network. Correct? So same as here. Now you are familiar with these terms, right? I'll tell you these terms later. Right? Okay. So now you tell me which is your standalone network here, which is your non-standalone network here. Which see just imagine this is your this diagram is 1, 2, 3, and 4. Okay. which is your standalone, which is non-standalone network. 1, 2, 3, and 4. 3 and 4, which is connected to the core network, which we can call it as this is standalone network, right? And this LTE, which will be connected directly to the core network, either or via this base station to the core network. Able to understand, right? This 4G network, 4G base station can connect either directly to the 5G core network or via the base station of 5G to the core network. That is yours non-standalone. So standalone is nothing but 5G, only 5G part. So 5G base station is used, 5G core network is used. Able to understand? Right. Now, how we are deploying from 4G to how we are slowly moved from 4G to 5G. Okay. So how that design, the architecture looks like. Right. So first, what is this EPC? What is the name? Evolved Packet Core. This is 4G core network. Correct? Right. And next, 5GC. This is nothing but 5G core network. That's what I've written here. I have written this is NR. Okay. So this is 5GC. Sorry. 5G NR is nothing but your RAN. Okay. Yeah. The RAN which is used for this 5G network. Okay. Now, what is this? ENTE, ENB? A mixture of 4 and 4.5G. Correct? So what is this? This is your base station. Correct? And this G node B is your 5G base station. Right? And this is your 4G. Correct? And this is your RAN. RAN is nothing but the radio access network, the radio signal which is used to access between the base station and the core and mobile equipment to the base station. Correct? Now, this is a simple diagram. Okay, now you can able to understand. Now we are deploying only this networks right now. Okay, that is you have considered this into 7 options. Okay, so what are all the possibility of options we can connect? We can deploy from 4G to 5G. We are going to see. Okay, the first option is E node B, which is connected directly to EPC. Correct, because this is the base station of 4G. Correct, and this is your core network of 4G. So when I deploy this, you will get one network. Correct. So this can access 4G network. Whenever we are using 4G network, okay, how the backside working is like this. That means your base station, which is connected to the core network of 4G, that which defines your 4G network. Correct. But what is our aim? We have to move from 4G to 5G. Correct. Now, the next option 2. This option 2 is GNP, which is connected directly to 5G. Correct? This is your entirely 5G network. And this is your standalone network. Correct? But this is not deployed as of now. I told you, right? Why? Because we need more number of hardware and software to install in this genome. So as of now, it is in the development stage. Right? Okay. Next, option 5. Option 3, 4, and 5 will give you, because we are talking about here is standalone network. Right. Next, this diagram will be non-standalone network. So first we are focusing on standalone network. So we'll have a mix of options will be there. Right. Now, option 5. So how it is connected? This, okay, the mixture of 4.5G, which is connected to 4G network 2 and also to 5G network. That is your core network. Correct? All these we can call it as standalone. Okay, so this one you know, because 4G base station which is used to connect 4G core network is standalone. 5G base station which is used to connect 5G core network is standalone. Now we comes to the non-standalone part. So this is very important part. Why? Because this part only we are going to see detailedly how your 4.5G, which is evolved to 5G. Right? Okay. Now, the first option, second option, option 5. This we have seen here. This is called a standalone architecture. Right? Now come to this non-standalone architecture. Okay. So non-standalone architecture means not the same base station and same core network which is connected. With the help of 4G or 5G, I can connect to the core network. Right. Now you see the first option, this option. They are taking the first option and they are creating a non-standalone network. Okay, because this is deployed already, this is standalone architecture. Now, EPC, E node B, G node B is there. Okay, so what we have done extra? We have included the base station of 5G. That we can call it as G node B. That means if you want to access this EPC, I cannot directly go directly to the EPC. It will go via E node B and it will access the EPC. Correct? Right. So this is one option. This option they are naming it as 3. And the next option is here we are using 4G core network. And they are taking here 5G core network. So here, the second option. This is the extension of first option and this is the extension of second option. They are introducing 4.5G base station here. This 4.5 base station which will be connected to G node B and from the G node B it will goes to 5G. Okay, so this won't be connected directly. So it won't be getting signal directly from the core network. So it will go via this and it will reach the core network. Right? And this third one, this option. 5G C, which is connected to ELT E node B, and this is connected to 5G base station of this option. Okay, so what the designer have done is they have the standalone network with them. Okay, and they are just doing a probability. Okay, among this, which one works good? They are checking like this. Because I cannot go directly to the 5G network. That is your entire standalone network. So I want to deploy 4G along with that 5G network. I can get to 5G. So now they have given 3 options. In that 3 options, they are checking this one is flexible. I'll tell you why it is. Okay, so they are going to focus on this network now. Okay, so this is the possibility of networks we can connect, right? But now they are taking option 3, okay, as more feasibility. Why? Because we'll see one way. Are you able to understand up to this line? Correct? So you know what is standalone, what is non-standalone network. Correct? So you know what is EPC, 5GC, G node B, ELTB, E node B, and G node. Correct? Right? Now, so from option 1 only it is moves to option 3, right? Okay, if you want to understand, just remember means what you have to do is just add 2, you will get this option 3. The standalone SA plus 2, you will get the non-standalone networks. So here also. Okay, and here also. Right. So I'll show that slide later. But first we are taking, so which options were? Option 1. Okay. So option 1 is moved to a non-standalone architecture of option 3. Correct? This is what here. Okay, by adding G node B base station extra. Right. Now you see. So from option 1, it is moved to option 3. Correct? Right. Now this option 3, they are replacing this E node B as E node B and ELT. Okay. Why? Because E node B, which is specialized for only 4G network. ELT is for 4.5G. So they are mixing E node B along with ELT. Okay. This is the next step. And the next step is here. What they are doing? They are transferring this entire network into a 5G core network. Correct? That means here you have 4G EPC. Here we have 5G core network. And this G node B, which is connected via this. So here they are interchanging the core networks only, 4G to 5G. And then finally they are deploying 5G network. Okay, this is one model. Okay, but they have not gone directly into it, but they are taking only this part and they are focusing on laterally about this. That is a big main advantage of this is because we are using user plane, control plane here. That we will see next slide. Okay, so this is the way of evolution from 4G network. So this is 4G network, right? Entirely correct. EPC E node B means the base station of 4G. This is your core network of 4G, and finally it is evolved to base station of 5G and to this core network of 5G. Right now, as I said, they are focusing only on option 3. So which is your option 3 here? This network. And they are going to modify this network to deploy 5G. Okay, right? That is what. Okay, so this is your this which network? I mean, which option? Option 3, right? Now, EPC, E node B, G node B, we are adding user equipment. Correct? So same, see here, this option 3 only I'm writing here like this. Right now, this option 3. So as I told you, even though if it is connected directly to EPC, but there is no direct communication between G node to EPC. If you want to send data or packets, anything will be goes via E node B and will reach EPC. So that's why they have disconnected this communication. Right now the real-time example. A user equipment, okay, the person who's having mobile phone wants to access the 4G network, 4G core network. Correct. So what happened is, as I told you earlier, you have user plane and data plane. Sorry, user plane and control plane. Correct. The first class, mobile edge computing, I have told you, enablers, 5G enablers. What is user plane? UPF, CPF. User plane, which is used to simply transfer the data, okay, from source to destination. Correct? Control plane, which is used to control the signal which is coming from source to destination. Correct? Suppose if there is any traffic between the source and destination, that will be controlled by using CPF to divert the traffic, okay, to reach to the another way, another path. Correct? And this user plane, which is simply used to transfer data. Data means what? Your voice, your video, or your mobile data. Okay, that will be passing through this user plane function. So control plane function, which is used to maintain the traffic. Okay, so that will be done by using CPU. Correct? Now you come to this EPC, which is connected to E node B via control plane and user plane. That is C means your control, U means user plane. Okay. So S1 is nothing but this is an interface which is used to establish a communication between E node B and EPC. S1 is an interface. Okay. So S1 interface which is used to establish a communication between EPC and E node B via two planes. One is control plane, another one is user plane. Correct? And next is this E node B and G node B which is connected via X2 interface. So interface, as I told you, is nothing but which will act as a medium to communicate between the two devices. Correct. And here also you have user plane and control plane. Right. Now see to this point, 4G E node P provides control plane connectivity towards the core network. Correct. 4G E node B, which provides control plane EPC to the core network. Correct. And 4G E node B act as a master node and 5G G node B act as a secondary. Why it is act as a master node? Because this is directly connected to the core network. So that's why we are telling this as a master node, this as a secondary node. Okay, so that's what if you want to send any data to the core network, that has to pass through 4G base station and it will reaches the 4G. Okay. And next, all user plane data in option 3 is tunneled through 4G E0B. That is what. Okay. So all data which is transferred from G0 to EPC that will be passed through E0B and reaches the EPC. That means if a user wants to, if a user in this G0B network, okay, if a user is standing near this G0B network, that is the base station, near the 5G base station, okay, with this entire network, they want to send data or voice, okay, what it will do, it will pass to the 4G base station network, and this signal or data will be passed to the 4G network. So it won't be directly given to the 5G network if you want to send any data if you are standing in a coverage region of G0. Correct? Why? Because there we don't have any direct connection with the core network of G. Right? If you have a direct connection with the EPC, it is easy, but it is not possible because the infrastructure of G0B is quite complex when compared to the core network of EPC. Correct? So they are testing with these examples whether we can deploy this model with the help of 5G base station. Right? The second point is DL. DL is your downlink. Data is split by E0B, PDCP layers between E0B and G0B. So downlink is nothing but from EPC to E0B. Okay. The data allocated to GNB is forwarded across X2 interface. Okay. So now what will happen? So any data to be sent over here that has to pass through this and you have to go here. Instead that I want to send the data from G0B to EPC. Okay. But which plane I can use? Simply you have two planes. Simply I want to transfer the data from G0 to EPC. I can use only user plane. Okay. So they have deployed. The second step is so I can use user plane to transfer the data from G0 to EPC directly. Because if you want to use control plane, it is very difficult. As I told you, the infrastructure is very modified between these and this. Correct? Right. Now, the data allocated to G0B is forwarded across X2 interface. Okay. So each and every process, it will follow X2 and reaches EPC. Right. Now, the drawback here is E0B needs advanced hardware to support high data rates of 5G. So as it designed to support 4G air interface. This one. Correct? So there is a big drawback in it. So if you want to send any 5G data to the network, that has to follow through this and it reaches the network. You cannot have a high modified hardware over here because it is a 4G based. So that is the main disadvantage when we doing this network. Okay. Slowly. Okay. Now, with this, I told you, right? I'm going to connect these two, right? And they are naming it as option 3A. Because we just want to give a name, right? Because this is one model, this is option 3. I want to mention another name, means I'm just giving a name as option 3A. Now you see this diagram and tell me what is happening exactly. Right. Now, you see here, I told you, right? S1 user interface, correct? Because I need to send the data directly from G0B to EPC. So I'm accessing only user plane. Okay. So I don't want control plane. Okay, because control plane is quite complex. Right. Now, 4G E0B provides control plane connectivity towards the core network. Correct? So this one which gives to the core network. 4G E0B act as a master node and 5G G0B act as a secondary node that we have seen in the previous slide. So this option 3A resolves drawback associated with option 3 by providing S1U interface between EPC and G0B. Correct? And still E0B decides which EPS bearer to be transmitted to E node B, but traffic split happens at EPC. So EPS bearer is nothing but this is a tunnel. Okay. So evolved packet core, this is nothing but your tunnel, which is used to transfer your data between core network to your E node B. That is your EPS bearer. Okay. The drawback is it does not support transfer of data over X2 interface. So now what happened is having this X2 interface, right? So instead that I'm just removing this interface because two planes only there. Removing this interface, I'm connecting with directly to the EPC. Now there is no data transfer between this G node and E node B, right? So what will happen? Now you tell me. See, I want to connect directly to this, but I don't want to connect between E node B and G node B. So I have removed this. But what is the drawback? The thing is, I told you, right? The user equipment, suppose a person who's having mobile phone is standing inside this coverage area of 5G base station. Okay. Suppose if he is moving towards this 4G network base station, cannot transfer the data, right? Right. So I'll just show this. This is that example. Right. So user equipment is in NR. Correct. So this is giving this G node B is I forgot to tell you this G node B, which is especially for data bearer. That is your data internet. Okay. So because mostly 5G needs more data rate to transfer your data packets. Okay. So voice call and this and all which will be taken care by 4G. Correct. So that's what this NR which is connected to G node B, which will provide your data bearer. Bearer means data, only data, tunneling data, right? And here this LT which is focusing on voice bearer. Okay. Now what happened? This UE, okay. So this NR is nothing but your 5G base station, and this LT is your 4G base station. So this user which is moving towards 5G. Okay. Now what will happen? How the data will take place? See this. So if the data, if the mobile which is moving towards this NR, okay, automatically the signal in LTE becomes T. Correct? If it is moving towards LTE, the signal becomes in the NR is weak. Correct? But if the signal is weak on this particular area, okay, so what will happen? Suppose the signal is weak in G node B. Okay, he wants to transmit the data. Okay, he wants to transmit data packets. Okay, but what we have to do? If you have a connection, user data connection between these two only, if the signal gets weak, it will pass through, bypass through it will go to the core network. Correct? So what we have to do? We have to have a user plane across this E node B and G node B. Same as if the signal becomes weak over here. Okay, if you want to transmit a data packets, faster data packets, that has to pass through G node B and has to go to EPC. Correct? So if the signal weaks between these two, the data transfer will not take place. Correct? So in order to overcome a solution, they are moving to this X2C, X2U. So what happened? This option, this we can call it as option 3x. So option 3, 3a, 3x. So how this will do? This 3x resolves drawback associated with option 3 and 3a by providing S1U interface between EPC and G node B and X2 interface between E node B and G node B. Now, if there is any weak signal between this and this, one will take care and will send the data, right? So that is what they are using. Again, they are providing one user face along with E node B and G node B. Correct? So now you have two user planes, one which is connected directly between G node B and EPC, and this second interface which is connected between E node B to G node B. So your data which is divided into two, if you want a fast internet or mobile data packets, you can connect directly from G node to EPC. If you want to go for any voice call, this thing, I can connect via E node B to EPC. Correct? So this is what your standalone non-standalone network. So this is the deployed 4G to 5G technology. This network. Okay. So far we are using only this network, right? So here you are using you are having a core network of 4G. Okay, but sometimes you can see your signal is moving from 5G to 4G. If you have a 5G signal also, sometimes it's moving to 4G, right? 4G LTE. Sometimes it becomes 5G. So that has happened like this because of this.